It was indeed a speech which, everybody is so encouraged right now by this. Now, let us move forward for award distribution. As it is rightly been said by someone that winners are those who convert the problems into opportunities, and it is the time to acknowledge all of those winners through these awards. I would like to request Shri H.B. Gajjar sir to please come upon the dais for the announcement of the awards.
Good morning to all. Guest of honor, Sri Amit sir, B.H. Patel sir, D.L. Pandya, and R.R. engineer. All my friends and delegate in the auditorium. You are most welcome on 30th National Conference on Boilers and Steam System, organized by Steamtech. Thanks to Saket for giving me the opportunity to announce the name of the winner of the award. Due to COVID, this time participations are very, very less. In my opinion, all participants are winners who has taken the part in the competition. A request to all, next year we require more and more participants to make this award function in healthy competitions. Now, without taking lengthy talk, I announce the name of the winner. In first category, boiler user as a manager or engineer. Person who win the first award as a best boiler user, as a manager or engineer, is a qualification is BE Mechanical, MBA, BOE examinations pass, NDT level 2, and certified energy manager. He has conducted in his own plant energy audit and improved the boiler efficiencies. Increased the boiler efficiency from 85 to 88. Increase the temperature of the PA air. Also increase the temperature of the inlet water of the boiler systems. And so many more changes. He has also installed sonic horns. The person who has won this award, name is Sri R.D. Zala. Inductotum, Kutch. Please come on the stage.
I would like to request Shri Amit Vyas sir to give away this award to Mr. Rajdeep Singh Jhala.
Congratulations, Mr. Jhala. In second category, best boiler operator is a boiler attendant. The person who wins this award is a junior engineer assistant in a boiler plant. He has a diploma mechanical, also passed the examination of first class boiler attendant from Gujarat state. He is continuously monitor the parameters of boiler and steam feed water. He also prevent the steam leakages in the steam plant and condensate line, and he get the results. I announce the name, Mr. Ronak N. Kakad from ONGC Hazira Plant Surat. Congratulations. Come on the stage, please. In a third category, best design in boiler and boiler parts. The person who has taken this award, he has done implementation of X-plate nano device on a FD fan of 3-ton gas fire boiler. And he got cost back payback period 4.5 months. I invite Manager Project and Maintenance, Sri Ankur P. Patel from Mica Organics Limited, Unit 2. Congratulations.
Thank you very much, Amit sir.
I request Mr. Ronak, what you have, how you achieved this by change. Please explain, Mr. X-plate organization.
गुड इवनिंग, गुड मॉर्निंग एवरीवन। ये एक एक्सप्लेट नैनो बेस्ड टेक्नोलॉजी है जो ब्लोअर अपना जो बॉयलर्स के जो ब्लोअर्स है अपना ब्लोअर्स के ऊपर सरफेस पे बिठाई जाती है और वो नाइट्रोजन और अपना जो क्लस्टर रहते हैं ऑक्सीजन और नाइट्रोजन के क्लस्टर को रिमूव करती है। तो जैसे ही नाइट्रोजन क्लस्टर रिमूव होते हैं एक्स प्लेट से तो वो क्या करता है अपना कंबसन एफिशिएंसी बढ़ाती है। जैसे ही कंबसन एफिशिएंसी बढ़ती है तो फ्यूल पे और CO2 पे अपने को सेविंग्स मिलता है। ये हमने 2 मंथ्स पहले इंस्टॉल किया था तो हमको 3 to 4% अभी गैस में सेविंग्स मिल रहा है लास्ट 2 मंथ से। थैंक यू।
Thank you. Thank you very much.
Thank you, sir. Congratulations to all the winners. And now I would like to request Shri Jayesh Shah to please come upon the dais to give away the Forbes Marshall Award.
Good morning, everyone, to this 13th Steam and Boiler System Conference, Steamtech 2022. In fact, we are meeting after a gap of 3 years. And it is really heartening to many of the known faces who have been, let's say, regularly attending this program. So thank you very much for coming together again. And let's continue with the same zeal. Just to, let's say, give you the preface of this Forbes Marshall Encone Award. In fact, this award we instituted almost, let's say, 5 years back. What we decided internally that since we have been participating in such forum, I think we just thought of that, let's look at the industry and what kind of energy conservation plans or projects they implement and what kind of savings they really accrue every year. And on the basis of that, in fact, what we decided that we approach the different steam users across Gujarat mainly and get them on board, just declaring that what kind of Encone projects they implemented and what kind of savings they accrued based on the entire steam system. When we talk of the steam system, it's right from the boiler, that is a steam generation plant, distribution, utilization, and what is getting recovered in the form of flash and condensate, and how it is impacted on the overall fuel bill. So every year, in fact, we have been getting a very good participation from all the steam users, cutting across all types of industry, whether it's food and beverages, pharmaceuticals, chemicals, tires, dairies, and in fact, textiles. Also, many of the plants, they really participate. So from the, let's say, this year, what we got the nominations, in fact, I just would like to brief you that most of the industry, they have participated. Their average fuel bill is ranging right from, I can say, 2 crores to 100 crores. And when we talk of their 100 crores annual fuel bill is, we do not, let's say, consider the fuel which is being, let's say, used for power generation. In fact, we limit this, let's say, evaluation only for the process steam utilization. So this is the range of the fuel bill, what let's say industry are at present using, and as we know that for steam generation, you have been using solid fuel, whether it is coal, briquette, or any other agro waste, natural gas, and liquid fuel. And based on, as we have been hearing since morning, I think whatever the fuel, because of the fuel price increase which has happened in last 1 year, I think every industry has witnessed their fuel bill jumped by almost, we can say, 50% to 70%. Just having the same set of, let's say, production, no change in the boiler capacities, but just because of this fuel increase, which is beyond our control, the fuel bill has jumped. And many of the industries, in fact, really started looking into how can we really now reduce the steam demand. The moment, let's say, you start thinking on these lines, that means it covers whether increasing the steam generation efficiency, reducing the distribution losses, using the steam efficiently in the process area, and ensure that everything is, whatever is possible in the form of heat can be recovered back, recycled, and put back into use. And this is how, let's say, we would be able to reduce the steam demand and in turn the fuel bill, right? So based on the nominations and what we really have done the evaluation on the same criterias in all the 4 segments of the steam system, we would like to, let's say, announce the winner for this Force Marshal ENCON Award. This is our 5th ENCON Award. Let's say, company Welspun Limited from Vapi, they are the winner for this year's FM ENCON Award. I just would like to invite Mr. Sachin Kanungo, who is a business head, and Mr. Vijay Patel, who is a overall engineering head, who are really are here to share their experience and also accept the award. Would like to brief you. I would not like to take out their thunder because they would like to make a small presentation. But their overall fuel bill is around 108 crores. And based on all the ENCON projects which have been implemented in 1 year, they could save almost close to 8 crore of the fuel in 1 year. So it is an excellent achievement. And congratulations to Welspun team. Thank you very much for being here. And I would request Mr. Amit Vyas, Mr. Purohit, Mr. Patel, please come forward and just hand over this award to Welspun team. Thank you. And my colleague, Mr. Mehul Vaidya, please come on the dais. I would request Mr. Patel to just share his experience on this journey. Thank you.
Respected guests on the decks and ladies and gentlemen, good morning everyone. Actually, last 4 decades, Welspun is in business of textiles. And along with the good product of textiles, we are always concerned about the sustainability. And recently, we have got one Sustainability Award from President of India. Actually, as said Vyasar, we have year and year we have reduced 9.8% of energy in specific energy conservations, many various efforts. And recently, against this award, we have done many energy conservation projects. And we have tried to harness all the waste heat out, whatever from compressor, effluent heat recovery, condensate heat recovery. Oh.
Yes.
right? So as I said, we have reduced 9.8% of energy saving year and year. So it's our energy conservation journey. So our project on the energy conservation, particularly for the condensate recovery, and our aim to harness all the waste heat out from compressor, effluent, condensate heat recovery, flash steams, that adds us a value of 8 crores per annum savings. So this is the total fuel savings, waste heat recovery projects, that adds 4.4561 metric ton of coal per annum. Condensate flash steam recovery, that adds 1079 metric ton per annum. And the process hot water recovery, that's just 2140 metric ton per annum. So overall 7780 metric ton per annum of coal savings we have able to add in our business. This is the calculations. This is some snaps of the, this is the P&ID diagrams of the project. This is the real pictures of the projects. This is recently we have introduced FJP from Forbes Marshall team, and that adds 4,000 metric ton of coal per annum from the condensate recovery project. Thank you very much.
Thank you very much, and many, many congratulations. And now I would like to request Sri Rohington Engineer, Director, Industrial Boiler Limited, Vapi, to deliver vote of thanks.
Good morning, friends. I have the pleasure to give the vote of thanks and summing up of today's morning session, inaugural session. I thank Mr. Amit Bhai Vyas, Managing Director, Amul Dairy, for being with us for the whole for the inauguration today. He has given us a very thought-provoking address. In fact, normally the guest of honor is a commercial man, and he would talk about so many things like politics and what Gujarat is and things like that. But in the 13 years, today we have an outstanding guest of honor who has given us a thought-provoking address. He talked about even heat pumps, heat pipes, and things like that. And it's a learning process, and most important, he said that learning never stops. So I hope that today's seminar will help us learn and improve our knowledge for the future. I also thank Mr. B.H. Patel for his presence today. He's also a guest of honor. And of course, we cannot just say that he talks only on safety. Safety is of paramount importance, and without safety, I think this world cannot exist. So over efficiency, I would say safety is to be given the first priority, then comes efficiency. Because just if we say that, no, because of efficiency, I want to reduce the safety factor, that is not acceptable. Of course, we had Mr. Satyara Purohit. He has been there with us always in all our SACET programs. And his speeches are very inspiring, and his practical tips are very useful to all of us. And I hope we all have taken it in the right spirit to see that we are able to implement what he has talked today. And of course, Mr. Pandya, he is the backbone of today's program, and he leads the SACET team. And we are thankful to him, most of all, that because of him that SACET programs are happening. And of course, Mr. Jainara Vyas is the man behind the mission, but his health is not good, as I understand from Mr. Pandya today. So we wish him a speedy recovery today. I also welcome and thank our former directors, Mr. Gajjar, Mr. H.B. Panchal, and other former directors of the Gujarat State Directorate of Boilers, and also the Office of the Directorate of Boilers, officers of the Directorate of Boilers being present here today. We have various chairmen, speakers of the technical sessions that will be there today, fellow delegates, members of the press and friends. Namaskar, and thank you for being here today. A very good morning. I have a pleasant duty to propose the vote of thanks on this inaugural session. First of all, I thank Saket Projects that we are thankful for you. On behalf of Saket Projects, I thank all of you for being present today on this 13th Steamtech and the National Conference on Steam Boilers, Steamtech 22. In fact, energy in many ways is a primary input and which fuels the economic growth of any country. With today's high cost of fossil fuels, oil, coal, today's seminar is going to be giving further insights in the post-COVID scenario. Everybody has talked in the inaugural session itself. I mean, never in the inaugural sessions they talked about that fuel costs are high, but today we have to hit the bullet, and we have to bite the bullet also and move forward to see how we can reduce our cost. Also, the inseparable part of energy is environment. So we need to work on environment in a bigger way, and the world is not going to sustain us for a long time. We have to see that we can we have one Earth, we don't have the second Earth. So one Earth, and how we can sustain it and how we can save our environment is going to be another thought or process. And of course, energy conservation is energy produced. So that goes without saying. We are also thankful to our various sponsors. I wouldn't take their name because Mr. Pandya has already mentioned them earlier. I'm thankful to the management of JB Auditorium for giving us this lovely air-conditioned room today. And we are able to sit comfortably and enjoy this program. I hope the press will give us a good coverage today for the sessions that we will be having. We thank the police of Ahmedabad for the consideration and help. And if you have any committed any protocol mistakes, please do excuse us. I thank you once again on behalf of Saket. Jai Hind. Thank you.
Thank you very much, sir. Tea infused very well. So can we start with the session 1 for the conference today? It is technical session 1 on managing cost competitiveness post-COVID. I request our session chairman, sir, Shri Rohington Engineer, sir, to please come upon the dais and occupy his chair. He is the Director, Industrial Boilers Limited, Vapi. He has been introduced in the earlier session. I would like to request Shri Prem Bhagwat from Forbes Marshall to please come upon the dais and occupy his chair. He is a steam engineering professional with over 17 years of experience. He's India's leading, from Forbes Marshall, India's leading process and energy efficiency firm. He's joined Forbes Marshall in 2005 as steam engineer and has handled various responsibilities in past 17 years to ensure process and energy efficiency at customer plants. I'd like to now request Shri Piyush Tiwari to please come upon the dais and occupy his chair. His professional experience includes Oil and Natural Gas Corporation Limited, Hazira, Oil and Natural Gas Corporation Limited, Hazira, AEE, Bharat Petroleum Corporation Limited. He is presently posted in cogeneration plant involved in operations and maintenance of gas turbine and boilers at ONGC. I now request Shri S. Sivkumar to please come upon the dais and occupy his chair. He's a B Mechanical. He's a professional boiler operational engineer, started his career as an engineer trainee and grown up at assistant general manager level, handled various responsibilities of commissioning, troubleshooting, performance testing, over 300 boilers of various types of EPC bases across the country, having capacity up to the project size of 300 megawatt. I now request our session chairman, sir, Shri Rohington, sir, to please take over the session.
Thank you, madam. And thank you very much for introducing all our speakers. As Mr. Prem Bhagat has already been introduced, I request him to present his paper for today.
Good morning to all. Once again, I would like to add a Vishesh from my side to Sanket projects for this 13th National Conference on Steam and Boilers at Steamtech Ahmedabad. And not taking much time on what has been said in the previous session, I think the dais is set now. We all know the background of increased fuel bill. But the good part is we all know that whatever we are talking, and we have seen in the presentation from Mr. Vyas that it is possible to do if we implement. So getting straight away into the implementation mode, we talked about the average 20% savings possible. Out of that, 7 to 8% from the process, 7 to 8% from the condensate recovery, and 5 to 6% in the boiler house. So I presume that boiler house will be covered in the post-lunch session, and right now what we are going to cover is the condensate recovery part, that how we can accrue these savings, what are the various avenues available in each industry, and then as we said that, and it has been said in the morning that don't label us as a dairy or textile, so we are going with the same concept. Condensate recovery is same irrespective of whichever plant you belong to. And we will talk of a generic issues and the generic solutions, how we can improve the condensate recovery. So first of all, when we started monitoring the condensate recovery industry by industry around three years back, and thanks to our director Mr. Purohit, we bring in a new terminology actually, which we said that should we monitor the condensate recovery factor instead of just talking on a condensate recovery. So I would like to take a 2 minutes over here and would like that everyone should come on a same platform and the same understanding level as of ours, wherein we are trying to say that whatever steam I am generating, I am sending it to the process, out of which whatever condensate I am recovering and again feeding it back to the boiler, feed water tank. So the ratio of that, we are calling it as a condensate recovery factor. So all the discussions and all our solutions would be towards increasing the condensate recovery factor irrespective of whichever plant we are operating into or irrespective of whichever industry we are belonging to. So we would be more than happy to connect with all of you and work together with you to improve the condensate recovery factor in each of your plants. So the first basic question which would be there, that why we should recover the condensate and what is flash steam. So flash steam, we all know that condensate is a high temperature hot water which is at a very high temperature, and once it is exposed to the atmospheric pressure, the steam will be generated which is called as a flash steam. If you see the quantity wise, the condensate will be around 85% and the flash maximum possible will be around 15%. If we generate the flash at more pressure, the quantity of flash may reduce to the 7-8% also. But if you see the energy wise, it is 50-50%. Why we have put in this particular graph? Because normally based on the quantity, we may feel that the flash is 7-8-10%, then why to put our energy or why to put our efforts to recover that flash along with the condensate. But the moment you see the energy content of that, I think the proposition will be more lucrative because the energy content in flash is 50%. So that's how on a energy content and on a amount content, the condensate and flash, this is again irrespective of any plant. Then what are the factors actually, and that's why we spent a time on defining what is the CRF. So which are the factors which will impact the CRF? So we have segregated these factors into two main buckets. One which is related to the steam and condensate system itself, and others which are related to the process dynamics. So if you talk of steam and condensate system, then the poor uptime which we talk in the first half, and which is the first basic step we talk about. So whether it's our traps, walls or any other leakages, we have to ensure that those are in line so that there is no impact on the condensate recovery factor. We have also seen that if trap type is not correct or if size is not correct, then we may have to open the bypass valve for attaining the process temperatures. And that is also one of the important reasons which will hamper the condensate recovery factor. And the third important point which Mr. Purohit also stressed in his keynote is the design aspect of the entire system. So if the design is not correct, sizing is not correct, or even if the layout is not correct, even if there is a system, everything is there, but we have seen that even layout can impact our condensate recovery factor. On the process side, again we spoke that we have challenges on capacity utilization as well as on the variable process parameters, consistency and the product mix, and we have a lot of manual intervention in all our processes. So all these factors actually cumulatively will impact on the condensate recovery factor. So condensate recovery factor, when we talk about, it's not only about putting one system and saying that now the condensate is getting recovered, but we'll have to look into the totality on all these factors, because all these factors will impact the condensate recovery factor, and we'll have to work together on all these factors to improve the condensate recovery factor in each of our plant or in each of our units. So knowing what is condensate recovery factor and knowing what are the things which are impacting that, now let us come to the what is the potential we have. So as I said in the beginning, irrespective of whichever plant we are into, our audit reports and our regular studies which all our engineers are doing is showing that in every industry there is a huge potential available. And the good part is, if you see the best numbers in each industry, the best numbers are even very near to the 95, and if you average it out, 70-75% of condensate recovery factor is easily available, is there are plants who are operating on that range. But if you see the average of the industry, and you can see in each industry there is a possible improvement, possible percentage to the level of 30%. So whether it's a pharma chemical, we can go to 75-80, but we are operating at 40-50. If it's a formulation, we can achieve as high as 95% condensate recovery factor, but we are operating at 65. Again, these are the industry average numbers. If we talk of solvent extraction plant and refineries, again we can reach to 65, but we are at 40. Textiles, majority of the textile users are over here, so we can get 50, average is 50, but we can take it up to 75. And same way for tire, dairy, Mr. Vass spoke about, so in dairy we can reach to 85, and the cow water which he was talking was a separate, and in rice also we can reach up to 70%. So the point here is, what we are trying to say is, whichever industry we are into, there is a immense potential available to reach up to the best, and whatever best we are saying over here, we'll have a case studies also wherein these best numbers are already achieved with a joint effort from Forbes Marshall and from the customers. So that's the potential, and we'll see that how we can harness that potential together. Now, knowing the potential, and before going into the solution part, let us also understand that there is a variation, and condensate recovery is not a static number, or it's not a static thing, but it is varying not only over the months, not only over the shifts, but even on the hourly basis. So again, the data which is coming to us shows that even if we plot it on a monthly basis, which is a much wider representation, the gap, or I would say the variation, is around 12%. That means we cannot say that the condensate recovery factor is fixed at 60% or 70%, but there is a variation even if we map it on a monthly basis. Coming to the shift, it's very obvious that moment from a month we come to the day or shift, the variation is more. It's to the tune of 15%. So variation is there, but what is the impact of the variation? The moment there is a variation in that particular period, whether it's an hour or a shift, for that particular period, my feed water temperature will be lowered, and because of that, makeup water consumption will increase, but it will also have an impact on the fuel consumption in the boiler, because increased feed water temperature will result into the higher steam to fuel ratio. Second is that lower steam to fuel ratio and increase in the fuel consumption. The second big issue with the inconsistency is that if my condensate recovery factor is low, then it is increasing the load on the effluent treatment plant. Because if condensate is not coming back to the boiler feed water tank, then it's going to the cooling tower, and then we put another extra energy to treat that water and further get back it into the process. So actually condensate recovery is not only helping us in recovering water, but it's also helping us in improving boiler efficiency, reducing our blowdown losses, and improving the boiler health in a sense, because condensate water is a pure water, and which will reduce our water treatment cost because the makeup water consumption would reduce. So it's though in terms of savings, we normally talk of the heat content in the condensate or heat content in the flash, what has been shown to you earlier. But if you really see all the savings, it's water savings, it's a reduction in the treatment cost of makeup water, it's a reduction in the cost which has to be done for the treating your effluent, and plus it's a increase due to the increase in the steam to fuel ratio. So it's having a multiple advantages, and it's I would say the very low hanging and the simplest thing in a plant to do, because we know the applications, and if we just I would say remove the direct heating application, all indirect heating application, whether the pasteurizers or whether it's a shell and tube heat exchangers or the reactors or the dryers, any equipment, I think with the correct process trapping we can recover the condensate. So there is an immense potential available, and there is a variation also, and we know what are the disadvantages of variation. So now we have to overcome all that. So for overcoming all that, we are suggesting you the 5 basic steps. So for sustaining the highest possible condensate recovery factor, we have to see right from the basics, and we'll just try to cover those things before going into the case studies. So the first and foremost thing is that what is the steam pressure I am giving to the process equipment. And as we all know, in case of steam, actually we get a higher latent heat at a lower pressure. That means my steam pressure to the process should be dependent on what temperature I need in the process, and accordingly we should be aiming to deliver the lowest possible steam pressure to the equipment to take the advantage of the latent heat. So and then the optimum steam pressure in case of direct heat injection also, it should be optimum based on the what temperature we need, because then it will reduce the live steam losses. Coming second to the process trapping. So as we all know, the importance of the trap is to remove the condensate efficiently and achieve the desired process parameters. So in case of, if we take 2 examples, one of chemical and one of textiles, we have currently a challenges wherever there is a multiple utility. In case of chemicals, along with the steam, we have an chilled water or we have an brine, and we always have an fear of contamination. And whereas in case of textile, any jet dyeing machines, there is a cooling water circuit also, and we have always a fear of that cooling water getting into the condensate and changing the properties of the condensate. So what's the new solution is into offering is we can call it as a reactor trap, or we can call it as a jet heat optimization module, wherein in current system, what is available today, we have a temperature based segregation available at each equipment. meaning we have to install valves which will operate on the temperature difference, and it will segregate the condensate and other utility. That is the current system available with us today. And any conductivity based measurement we are doing common for a reactor block or for a plant. So that these two discrete systems, we have tried to club it together with the help of the reactor trap, wherein temperature based variation as well as the conductivity based variation will be monitored at a equipment level itself, so that there is no possibility of contaminated condensate going into the common system. So in the process trapping, of course we have to see for a correct trap sizing and the correct trap type, but this is the new innovation which will help us in improving the condensate recovery factor to the optimum level. So the first was having correct pressure, second was having correct type of process trapping. The third and a very new innovative thing, so in the morning we spoke about the barcode and scanning it and someone taking an action. I would say that is also a very tedious process. We are now ahead out of that, and we have a just simple indication on the trap which will show whether the trap is working or not working, and while taking round anyone can see that and can then take a corrective action. So this is available for all process traps, and it is having it's an LED base and which will having a 4-color indication. As you can see, if it's a green, trap is working okay. If it's a blue, the process is not currently in a use. If it's a red, then the trap is leaking and we need to take a corrective action. And if it's a magenta, then it's a trap which is failed but in a closed condition. That means the water logging is there. So it's a very simple solution which will tell us the trap uptime right there, whether it's working, not working, and we can take a corrective action there itself without working for any further instruction. The fourth one, as I shared with you in the very first slides, the flash steam recovery. So the quantity is very less, but the amount of heat is 50%. And if you can see, right now we have developed a solution in which we can recover the flash steam as well as condensate and the secondary flash, because in our conventional condensate recovery systems earlier, whatever motive steam we supply, the secondary flash will be venting through the pump receiver that you must have seen in each of your plant. So this system will utilize the secondary flash also, and we will get a condensate temperatures which are in excess of 100 degree. The another advantage is footprint area required is 1/3 or 1/4 of the earlier conventional systems of separate flash vessel and a separate condensate recovery system. And if you can see, the incremental energy recovered is also more than 5 to 6%. No venting. Most of the process audits requirement, or most of the plants today have stringent requirements wherein they don't want any I would say any venting in the atmosphere. So this is a perfect system wherein there is no venting. And if you can see, most of you would have observed that the earlier your condensate recovery systems would be in a pit to ensure that there is no back pressure created on the system. So we are avoiding all pits and everything over here. And we have also seen in the case of Welspun, they have already implemented this system, and it's not only Welspun, many of the customers across the India have gone ahead with this innovative solution, and we'll talk more about the same in the case study. So the first was having correct pressure, second was having correct trapping, the third was a trap monitoring, the fourth was a flash steam recovery, and the fifth and very important thing is that the entire condensate recovery system, or I would say that whether the entire plant is running optimum, is running or not running on an optimum level, can be very well known just by having a diagnostic of a feed water tank. So as we said in the morning that boiler is the heart of the plant, I would just extend that along with the boiler, feed water tank actually is the heart of the plant, and at feed water tank we can just come to know whether our heart is working perfectly fine or not. So if you can see, what we recommend is that first the feed water tank should be of correct size. Because if we do all efforts in condensate recovery, flash steam recovery, and if feed water tank is oversized, then my radiation loss will increase, and whatever efforts we have put into will result into the reduced feed water temperature. Second is that feed water tank is a place wherein we should continuously monitor the pH and TDS. It's a place from where we are sending the water to the boiler, and the health of the boiler and the tubes is very important. So that's the place where we should monitor, and we should have a proper diagnostic and the control also. The third is at feed water tank only we are mixing the flash, condensate and the makeup water. So it should have a system in terms of deaerator head based on again your type of boiler, whether it's atmospheric or pressurized, but we should have a proper deaerator head which will ensure the proper mixing of all these three utilities. And then we should have an also digital measurement of makeup water, because end of the day whatever condensate we are recovering, that should reflect into the reduced makeup water consumption. And the moment we have that measurement of makeup water, temperature of the feed water tank, and then the pressure of the flash steam, I think we will be able to just say whether the plant is running in a good condition or not, just by observing these 3-4 parameters. And if these parameters are well within the control, I think then the entire our trapping system, entire our pressure usage in the plant is correct, and entire condensate recovery and flash steam recovery is coming back to the plant, that can be ensured. So more and more we will request you to monitor all these parameters in the feed water tank with the help of all the gadgets which are available. We'll just go through a couple of case studies, and then rest of the things we can discuss in the question and answer session. And this will talk about how our solutions have enhanced over year on year, and how the customers are getting benefited. So this is a chemical manufacturer in the Gujarat. If you can see, in 18-19 when we started working with them, the condensate recovery factor was 45%, and we selected a few equipment, solvent recovery section, to improve the condensate recovery factor by working on the process trapping solution. So the earlier process trapping was not able to evacuate the condensate, because we know that in a solvent recovery section, again the process temperature requirement was very low, 90-92 degrees Celsius, and the trapping was not able to evacuate the condensate because of the stalling or because of the back pressure being higher than the motive steam pressure. So we have taken a corrective action on the process trapping, which has impacted the increase in the condensate recovery factor from 45 to 57%. While the condensate recovery factor was improved, there were benefits on the process side also, wherein the ramp up time improved by 35 minutes, half an hour, and the optimum reflux ratio were maintained. Plus earlier whatever fluctuations were there in the column, those also minimized. So this was a starting point wherein we improved the condensate recovery factor from 45 to 57%. Then we started working on their ETP plant, which is multiple effect evaporator. So there we have proposed them again correct trapping for ATFD, utilizing the flash steam of ATFD into the stripper column, and condensate and flash recovery. So what we talked just a few slides before. So here from entire MEE section, the flash steam is utilized, all the condensate is getting recovered, and you can see earlier we reached from 45 to 57. So 57 has been taken to the 68% as a condensate recovery factor for the same plant. And again in MEE also there were process benefits, wherein the feed concentration was optimum, and again MEE batch time reduced by 22 minutes. Next, the customer is same, the current year. What we have worked is that on each reactor, and which I spoke about, that the condensate recovery was not happening because of the multiple utilities. So we have given them a reactor-wise trapping solution along with the trap monitoring, which has ensured that from each reactor I am able to recover the condensate, which has also had an impact on their batch timing. And now we have an improved condensate recovery to the 78%, and we have seen that in the chemical what is best we can get is 78-80%. So it's very much possible if we actually take a step by step and try to hit the highest possible number. And in each of these examples you must have seen we have worked on a process trapping, we have worked on the flash steam recovery, we have worked on the correct steam pressures, and we have worked on the trap monitoring also. Going to the next. So this is just a dashboard which is showing what all has happened, wherein you can see the feed water temperature has increased now to 90 degrees Celsius, and the makeup water consumption is 24 TPD, and condensate recovery factor is 75%. So that's what we are saying, that we should be able to monitor everything on a dashboard so that we can take a corrective actions. Just one more case study, textile plant in Surat. You can see the before scenario. If you see the before, again there is an improper condensate evacuation which will result into bypass opening on a jet dyeing machines, and because of that the process trap is having a low uptime which will impact condensate recovery factor. Additionally, condensate going to the ETP, so it's increasing the effluent treatment cost. What we have done, again a proper trapping system with online trap monitoring to start with, then a condensate recovery system which will recover the flash as well as condensate, and a feed water tank solution which will show all the parameters and a diagnostic to take a corrective action. If you can see on the right hand side, what is the impact because of that? The process trap uptime, which was 72%, has reached to 98% now. The condensate recovery factor, which was 35%, has reached to 60% now, and the feed water temperature, which was at 70 degree, is at 92 degree now. So a small steps, very proven steps, but you can see the impact across all the important parameters in a process plant. The same thing we talk about, you can see in the middle, even in a cluster like Surat, people are going ahead with the online trap monitoring system, and you can see in the middle it will blink to a green every 30 seconds. In fact, in all lockdown and in the COVID time, we have a request wherein there were issues of the manpower and no skilled manpower available. So most of the places people are finding it convenient to go with an online trap monitoring system, so that they need not to depend on the maintenance staff, but they themselves get I would say feedback and then take a corrective action on that. A dairy plant in Gujarat, again it's a pasteurizer. Running very short. So 1 minute, yeah. Thank you. So I'll not go into the detail, but again the same thing, the proper trapping, proper temperature control, then the proper equipment level hookup and a condensate recovery. So all that has been done, and you can see what are the savings, and the savings are mind-boggling actually. You can see the 20%, 23% in fact reduction in the fuel consumption, 10 kiloliter reduction in the water consumption, which is close to the 46 lakhs in terms of monetary savings, and condensate recovery factor you can see from 37 to 89, and feed water temperature going to the 75 degrees Celsius. So that was the last slide. So I think in each industry there is a huge potential available to us, and all the solutions are proven solutions. So we can work together actually to improve the condensate recovery factor, which will reduce our makeup water consumption, which will reduce our fuel consumption, which will reduce our water treatment cost, and which will enhance our, I would say, the monetary savings. So that's all from my end, and we can connect one-to-one also post this session to take this ahead jointly along with you. Thank you everyone, and thank you Mr. Rohit.
Thank you, Mr.